Hello everyone, welcome to my channel Matrix IIT Academy. In this video, we are going to learn about the LCM and also HCF. So how to find the LCM and HCF of the given two numbers means, first we will find the prime factors of the given numbers, and after that we will find the HCF as the product of the smallest power of each common prime factors in the numbers, and LCM is the product of the greatest power of each prime factor involved in the numbers. So that way we will find the HCF and LCM. So, and for any two positive integers A and B, the product of the two numbers is equal to the product of the HCF and LCM. So now we will see some shortcuts in finding HCF and LCM, because in some word problems which are related to HCF and LCM, we will get confused whether we have to find LCM and also HCF. So to avoid that confusion, so here these tricks will help us to find in which case we will have to find HCF and LCM. So in the first case, we need to find the greatest number that will exactly divide PQR, then the required number is HCF. That means here HCF means, of course, HCF of the numbers is also the factor of the numbers. That means here this number is divides exactly the numbers PQR. Means when you are dividing the numbers with this HCF, you will get the remainder 0. That's what the mean by exactly divide. So here we will see one example. So greatest number that will exactly divide 65, 52 and 78. So here greatest number that will divide all these numbers means finding HCF. So here 65 factors, prime factors are 5, ones are 5, here 5 threes are. So 65 means here 5 into 13. Next 52. So 52 means you can carry on with the 2. So here 2 2s are 4. And here remainder 1, 2, 6 are 12, and here 2 again, 2 1s are 2 3s are. So 52 means here 2 square into 13. Next 78 can do with the 2, so 2 3s are 6 and remainder 1, and 2 9s are 18, and 3 1s are 3, 3 3s are 9. So 78 prime factors are 2, 3 and 13. So now HCF is nothing but the product of the least power of the common factors in the numbers. So here the prime factors already be found here. In this the common factors you can see only 13. So the 13 is the required answer for the question. Okay. So here we will see the next case. If we need to find the greatest number that will divide PQR and living remainders A, B, C respectively, then the required number is HCF of P minus A, Q minus B and R minus C. So here we will see the example to understand this case. So greatest number that will divide 65, 52 and 78, leaving the remainders 5, 2 and 8 is. So first here we have to subtract the remainders from the numbers, and hence we will find the numbers. So 65 minus 5 means here 60, and next 52 minus 2 means again 50. Next 78 minus 8 means here 70, and find the prime factors of the 60. So here 2 into 3 into 10. So here 2 into 25 means here you can write 5 square, and 7 into 10. So here this means here we can write 10 into 5 simply. So in this common factor is 10. So common factor means here HCF is 10. Okay. So this 10 is a required answer. That means here when you divide all these numbers with the 10, you will get the remainders 5, 2 and 8 respectively. So it is very simple to understand this. So 65 by 10 means here remainder 5. That's what. 52 by 10, remainder 2. 78 by 10, remainder 8. So in this case, we have to use this technique. Okay. So next we will see the third case. If we need to find the greatest number that will divide PQR and leaving the same remainders in each case, then the required number is H.C.F of P minus Q, Q minus R and R minus P. Means simply we will subtract the numbers from among them only. So here we will see the example. The greatest number that will divide 65, 81 and 145 leaving the same remainders in each case. So leaving the same remainder means here first we have to find the difference of the numbers. Okay. So here 65 and 81. So when you subtract this 81 from 65, you will get a negative number. So here we cannot find the HCF. So what I am doing means here I am subtracting the 65 from the 81. Okay. So that way we will follow. So here 81 minus 65. Here 11 minus 5 means here 6, and here 7 minus 6 is 1. So 16. Next 145 minus 81. So 5 minus 1 is 4, and here 14 minus 8. So here 64. So next 145 minus 65. 5 minus 5 is 0, and 14 minus 6 is 8. Okay. So now we have subtracted this. So now we have to find the HCF of all these numbers, so that you will get the answer for this question. So 16. So 16 prime factors are what? Here 2 power 4. So 2 is only the factor. So 2 2s are 4 and 4 4s are 16, like that. So 64. So 64 means here 64 means here we can write 2 power 6. 2 power 4 6 is 64, and here 80. So here 80 means here 2 power 3 is 8, and again we will get 1 2 from the 10. So here 2 power 4 into 5. So here we are finding the HCF, so that here we will concentrate on the common factors. So common factor is 2, and the least power in the common factors, least power among all these 4 6 is 4. So that 2 power 4 means here 16 is our required answer. That means when you divide this 65 by 16, you will get the same remainder in all the cases. Means here like 81 by 16 and 145 by 16, you will get the same remainder in all these cases. So this was the third case. So if you observe the difference between these three cases, in the first case here we have exactly divide, means the remainder 0, but in the second case different remainders, but in the third case we have same remainder. So that's what the difference between the three cases. Okay. So the same way we will see the LCM. So in this LCM also we have three cases. First one is without any remainder, means remainder 0, next same different remainders, third case is same remainder. So case 1, if we need to find the least number which is exactly divisible by PQR, then the required number is LCM of PQR. We will see the example. Least number that will divide, that will exactly divisible by 6, 5 and 7. So exactly divisible by the numbers means that number must be greater than this number. Means when you are dividing that number, the resulting number with all these 6, 5, 7, you have to get the remainder 0. That's what the meaning of the divisible, exactly divisible. So here, so first find the 6 prime factors of 6 and 2 and 3, and of course 5 is a prime number and 7 is also prime number. Okay. So here LCM is nothing but the product of the greatest power of each common factor appeared in the given numbers, so are present in the given number. So here there is no common factors here. So here product of all the factors is nothing but our required number. So 5 2s are 10 and 7 into 3 21. So 210 is our required LCM of the given number. So 210 is the least number that will exactly divisible by all the numbers 6, 5, 7. Next, the second case, if we need to find the least number which when divided by P, Q and R leaves the remainders A, B, C respectively such that P minus A, Q minus B and R minus C is equals to K, then required number is LCM of P, Q, R minus K. Means here the difference of the numbers from its respective remainders gives a constant. P minus A is equals to Q minus B is equals to R minus C means the difference of the numbers with respect to its remainder is a constant, then only we have to apply this trick. Then the required number is LCM of the numbers PQR minus the constant K. Okay, so here we will see the example. Least number that when divided by 6, 7 and 9 leaves the remainder 1, 2 and 4 respectively is what? So here different remainders, also this condition must be satisfied, then only we can apply this. So here 6 minus 1, 5, 7 minus 2, 5 and 9 minus 4 also 5. That means here we have got the value of K. The difference between the numbers and its respective remainders are equal to the constant K. Okay, so that the required number is LCM of the numbers 6, 7 and 9. So here 2 into 3 is 7 is a prime factor and here 3 square. So now LCM of the numbers 6, 7 and 9 is nothing but again product of the greatest power of the common factors and the remaining factors. So here common factors are 3, but here the power is 1 and 2. So among 1 and 2 greatest is 2. So here 3 squared and the remaining factors are here 2 and also 7. So 3 3s are 9 and 9 2s are 18. 18 into 7 126. So here 126 is the LCM of the numbers, and now we have to subtract the constant from the number. So here LCM of 6, 7, 9 is equals to 126 minus, here minus K when you write, so minus 5 means here 121. Okay, so here 121 is our required answer for this question. So next case 3, if we need to find the least number which when divided by P, Q and R leaves the same remainder A in each case, then the required number is LCM of the numbers plus the same remainder. Okay, so we'll see example. The least number which when divided by 8, 9 and 12 leaves a remainder 1 in each case is what? So here first we have to find the LCM of the numbers. So here 8 means here 2 power 3 and 9 means here 3 squared and here 12. Here 12 means here 2 power 4 into 3. Okay, so here LCM is equals to, here the greatest power is 2 power 3 and here in the 3, here 3 squared. So here 2 to the 4, 4 to the 8, 8 9s are 72. So 72 is the LCM of the numbers 8, 9 and also 12, and the required number is 72 plus A means here 1. So here we have to add 1, so 73. So 73 is the least number when you divide it by these numbers 8, 9 and 12, you will get all the time remainder is 1. That's for the case 3. Okay. So next we will see how to find the HCF and also LCM of the fractions. So HCF of fractions is nothing but HCF of the numerators divided by LCM of the denominators. And similarly LCM of the fractions is nothing but LCM of the numerators divided by HCF of denominators. And HCF of the three numbers PQR is nothing but product of the numbers PQR and product with the LCM. So LCM of PQR divided by the product of all the two LCMs of the two numbers. So here LCM of PQ into LCM of QR into LCM of PR. Next LCM of PQR is equals to P into Q into R into HCF of PQR divided by HCF of P comma Q into HCF of Q comma R into HCF of P comma R. So this way we will find the HCF of the fractions. So that's all about the HCF and LCM. So thank you for watching.